All right, advent of code, day 13. Here we go. Whoa, okay. Day 13, shuttle search. Your ferry can make it safely to a nearby port, but it won't get much further. When you call to book another ship, you discover that no ships embark from that port to your vacation island. You need to get from your port to the nearest airport. Shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often the bus leaves to the airport. Bus schedules are defined on a timestamp that measures the number of minutes since some fixed reference point in the past. At timestamp 0, every bus simultaneously departed from the seaport. After that, every bus travels to the airport, then various other locations, finally returns to the seaport to repeat its journey forever. The time this loop takes a particular bus is also its ID number. Okay. Stirs ID equals stirs 0.2i. First line is your estimate of the earliest timestamp you could depart on a bus. Entries that show X must be out of service, but you decide to ignore them. Bus in service equals stirs 1.map split 2i dot compact puts in service. Okay. You can save time once you arrive. Your goal is to figure out the earliest bus you can take to the airport. Here the earliest timestamp you could depart is 9:39. So you need in service dot map bus ID ID over in service is so it's the modulus ID mod bus ID bus ID minus delays equals that. Delays delays dot index delays dot min times delays dot min. bus ID equals delays. What? Oh, in service. Oh, it's just 3464. 737, brutal. Shuttle Company is running a contest. 1 gold coin. For anyone that can find the earliest timestamp such that the first bus ID departs at that time and each subsequent listed bus ID departs at that subsequent minute. Puts delays in service.inspect. Are they all prime? Yes. So, oh, that doesn't really help. Oh. Such that the first bus ID, earliest timestamp such that the first bus ID departs at that time and each subsequent bus ID departs at that subsequent minute. Oh, I see. Each index each index each with index n x n x select n greater than 0. Oh. 13.1, 59.4. Okay. All right, so this is some Chinese remainder theorem stuff that I don't know how to do. So these are all primes. And we have some fixed offset of each of them. Let's see. If we just had like 7, 1, and 5, 3, then mod 35, that's like, what does that give us? So that's like 1, 8, oh, okay, that 4, 2, 1, 8, 15, 22, 29, and this would be 2, 7, 12, 17, 22. And how do we find that? I don't remember my theory. Oh, I can do it for each subsequent one, and then each time I jump, I jump by the product. So offset equals 17. T equals 17. Product equals 17. In service dot skip 1 dot each do n mod while t mod n not equal mod t plus equal prod. Prod times equals n puts t. In service dot each do n mod puts t t mod want t mod n equals got oh. While t is greater than seven. Oh. It departs at 0. Oh god. T equals 1068781. Huh? 19. Oh. This should finish. What's in service.inspect? Oh. Ooh. In service equals in service dot sort by n x n. Does that still work? Yeah. Oh. Interesting. Why is it taking so long? Oh, because some of these are greater than. Oh, okay. What does that mean then? Um, T plus N mod. No, that's not the right answer. What, why did I sort? Okay, I don't know if I got this right. Zrankiewicz, are you done already? No? Interesting. $24 seconds. 20 seconds. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 239. Yes, let's go. All right, I'm pumped about that one. That one was good. That one was real good. All right, let's review. Day 13. All right, day 13. This was an interesting one. Shuttle search. Your ferry can make it safely to a nearby port, but it won't get much further. When you call to book another ship, you discover that no ships embark from that port to your vacation island. You'll need to get from the port to the nearest airport. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedules are defined based on a timestamp that measures the number of minutes since some fixed reference point in the past. Okay. In timestamp 0, every bus simultaneously departed from the seaport. After that, each bus travels to the airport and various other locations and finally returns to the seaport to repeat its journey forever. The time this loop takes, a particular bus, is also its ID number. The bus with ID 5, what's up, Dave Core 82? Yeah, do it. They're just starting to get difficult. So up until now, you know, they're all like pretty straightforward algorithmically. But now we're getting to the point where like you actually have to think about like how would you solve this problem, which makes it a little bit more exciting. It's not just like a pure how fast can you type, you know, how fast can you type something, but it's actually like how quickly can you figure out how this works. So like today I was like 700th place on part 1, but like 237th I think on part 2. Highly recommend it. The bus with ID 5 departs from the seaport at timestamps 0, 5, 10, 15, and so on. Your notes consist of the puzzle input consists of 2 lines. The first line is your estimate of the earliest timestamp you could depart on a bus. The second line lists the bus IDs that are in service according to the shuttle company. Entries that show X must be out of service, so you decide to ignore them. Okay, so here's our input. 13.input. This is our bus ID. And then our in-service things are these, and we just strip out the X's. Which this I guess works. I call 2I on everything, which returns 0 for non-numbers, and then I just get the positive ones. But I could have just filtered out the thing equals X, whatever. The first in line is your estimate of the earliest timestamp you could depart on a bus. Second line lists the bus IDs that are in service according to the shuttle company. To save time once you arrive, your goal is to figure out the earliest bus you can take to the airport. There will be exactly one such bus. I suppose you have the following notes. If you look at what happens after 9:39, bus 59 is the first one that you can get to. Thanks for the follow, Dave Core. So 944 divided by 59 is 16. Which is key. So that's cool. So the earliest bus you could take is bus 59, and it doesn't depart until timestamp 944. So you need to wait 5 minutes before it departs, and you multiply those 2 things together to get part 1. To get the delays for each service, do the bus ID minus ID mod bus ID. Okay, I don't even understand how this works looking at it. Let's see. Puts part 2. No time for comments when you're trying to do it as fast as possible. 3464. Does this give the same answer? No. Bus ID. So this is like 59 minus my giant number. Yeah, this is a speed contest. This was the leaderboard for today. So the top 100 people get points, and someone solved this part 1 in 4 minutes and 21 seconds, and 16 minutes and 14 seconds was the 100th fastest time for part 2. Did I stop my timer? Yeah. delays. Oh, okay. That's what that is. I just needed extra parentheses. Okay, so the ID, mod the bus ID, gives us like the point back here. Yeah, or ID mod the bus ID gives us like -5. Gives us like 54, I think. Let's do it for 7. 939 divided by 7 is mod 1. So then 7 minus 1, yeah. So this gives us like mod 1 for 7, or this bit, is how many equals how many minutes since last departure of bus ID. And so technically, if one of these were 0, if one of these left, yeah, so because it's like times the delay, he wouldn't, if the delay was 0, your answer would be 0. So I think he probably prevented having 0 as an answer. So then the delay is the minimum delay, and then the bus that you take is the delay. You get the index into the delays, and then you look that up in service, which is the buses, and that's the taken bus ID, and then you multiply those two together. Yeah, that makes sense. Cool. So then, that was tricky. So then part 2, even trickier. What do we got going on for part 2? Shuttle Company is running a contest. 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID departs at that time, and each subsequent listed bus ID departs at that subsequent minute. First line in your input no longer relevant. Suppose you have the same list of bus IDs as above. An X in the schedule means there are no constraint at what bus IDs must depart at that time. So bus ID 7 has to depart at timestamp T. Bus 13, because it's index 1, must depart 1 minute after timestamp T. No requirements for 2 or 3 minutes after. Then bus 59 has to depart 4 minutes after timestamp T. Wait. The only bus departures that matter are the listed bus IDs. Those bus IDs can depart at other times, and other bus IDs can depart at those times. In the list above, because bus ID 19 must depart 7 minutes after the timestamp at which bus ID 7 departs, bus ID 7 will also be departing at the bus 19, and that's fine. Okay. Wow. Good thing I didn't read this, because this would have been super confusing. Cool. So that's what we are looking for. But this is going to be a super high number, so we need to be intelligent about how we look for this number. So we're basically doing some like Chinese remainder theorem. So I first get each bus and their mod here. So if we open up our input again, So the in service looks like 17, 0, and then 41, 7, I guess. Array of bus ID and delay modulus. So the way that we're going to do this is I wrote some scratch notes over here. Basically, if you look at 7, let's say you have the numbers 7 and 5, and you want to find a number that's equal to 1 mod 7. So the key thing here, is this value is equal, this value is basically equal to 0 mod 7, negative 1 mod 13, negative like 4, 59. So what you can do is, let's say you found something that fits these two, then the only next time, because these are relatively prime, because they're both prime, the next time that these two will occur right after each other is after their product. Basically, the Chinese remainder theorem says, like, if you have two numbers that are relatively prime, and you have the modulus of 1, and you have a modulus relative to 1 and a modulus relative to other, there's exactly one number between 0 and their product that has both of those moduluses. And so to find the next increment where you have like bus 7 leaving at bus 7 and then 13 leaving 1 after, you have to go, let's see, 7 times 113, 91 later. So 1068781 divided by 7 is even. By 13 is, this is basically 12/13, 92.92. So the next time that happens is plus 91, where you still get 0.92 and 7 still evenly divides it. So we need to get to this super high number, but the idea is that we can move along in big strides the more numbers that we've sort of like locked in. I don't need that, I don't think. Yeah. So at first we have our timestamp is 17 because it leaves at 17, and then basically our like stride length is also 17. So then for every bus, we want to increase our starting timestamp by, does this run? Oops. I don't think so. Yeah. While the timestamp plus the delay is not divided by the bus ID is not 0, we need to take a big stride. Then once we get to the end, we've like locked in that bus. Oh yeah, sort of like a good inductive way to prove why this works is let's see, does this work like this? Yeah. Oh. Ooh, okay. I don't really know what's up with that. Oh. 1. There we go. So, okay, clean this up a little bit. So take T. T is our starting timestamp. At the end, for every single thing, we are prod is 1. Basically, we can like prove this inductively that after each iteration of this, T mod T plus the mod for all the previous things divided by the bus ID will always be 0. Or, what's up, Mr. Person? Yes, I did notice that all my inputs are prime numbers, and that's exactly why this works. So, because we only, we say that, so we're modifying T here, but then, and we're modifying T here, and we're trying to find a T such that it fits some constraint mod N, and then we're always incrementing T by product. But then after we find a T that satisfies that constraint mod N, we then multiply our product mod N times N. And so when we increment T by the product, T mod N won't change. So that's what I mean by like locking in each bus ID. And we just do that for all of them. Yeah. I don't know. That was kind of hard to explain, but it works. Let's see how everyone did. Print leaderboard. Yeah, I did poorly on part 1, but I was pretty satisfied with part 2. It's like, that was a hard problem to figure out. There were some tricks with like the mod being at negative mod or mod that I didn't really quite grasp right away. But I figured it out. How about this leaderboard? Holy moly. Zranguitz, you did part 2 in 4 minutes? That's insane. Ha 4 minutes? Let's see. Zach Croman. 224 to 524. Zach Croman did it in 3 minutes. 637. 224. You did part 2 faster than this second place guy. How? Okay. That's pretty wild. Yeah, cool. I think that's all for Advent of Code, day 13.